Dear Morgan Field, I want you to know that Sam Stanley is superior to you in so many ways as a math student. Number one, because she actually showed up to math today. She made it a priority. And trust me, she's got so many better places to be, like the mall or sleeping or eating or something. But she's here. So take that, Morgan Field. Yeah. All right. Well, we got to get started, guys. This is a long lesson. So we got to check this out. We want to do logarithmic and exponential word problems today. And we'll try to get through as quickly as possible, but I got about 6 examples and some problems for you to work on. You're going to have some time tomorrow to work on this, but not necessarily the whole hour. We'll introduce a new topic. You won't have an assignment tomorrow, though. So how about that? Your review assignment that you got the other day, what I gave you yesterday, and then what you get today, that's it for this week. But we will cover a little bit of material tomorrow. So anyway, Precalculus Unit 4 notes. We want to talk about compound interest and continuously compounded interest. Now, this is different. For example, if I buy a home, I bought my home for around, say, $110,000. I don't actually pay $110,000 for that home. Do you know what I pay for it? More like $200,000, because I pay so much interest over the course of a 30-year mortgage that I end up paying probably double what the house is actually worth. That's unfortunate, isn't it? But that's life. The flip side of it is that I put $1,500 into a Roth IRA, and it gets, interest collects on it every so often, and lo and behold, that $1,500 turns into $8,000 after a few years. So it can work for you, it can work against you. You need to invest your money and have something work out. Well, I want you guys to notice something right away, and then we can try these problems. But this is how we calculate compound interest. A is the amount. P is the principal. Principal means the money that we initially put in, okay? So that initial amount. R is the interest rate per year. N is the number of times it's compounded, and T is the number of years, okay? Now, I could derive that formula for you, but I don't want to. What I do want to do is show you this. If we were to compound it many times, let's say we were to compound it 1,000 times over the course of the year, this expression right in the middle there becomes the number E. If you were to carry that out to infinity, you would come up with E. If I took 1 plus 1 over n to the, say, 1,000,000th power, I would come up with 2.71. So that's what it means to be continuously compounded. What is continuously compounded? Well, interest might be compounded, say, once a year, twice a year, 4 times a year, but continuously compounded, that's like the bacteria that grows under your toenails. That doesn't just grow every couple days or every week or every year. That's growing right now, isn't it? Right? Amanda, you got some green fungus growing under your toenails, right? And it's just continuing to grow until you take that weekly shower, right? Okay, so Whitney, thank you for coming on in. Whitney Rasmussen is so superior to Morgan Field. Okay, and Sam Stanley even beats her. So, okay. And T-Wick is a lost cause. So, because he's playing with his cell phone right now instead of paying attention. iPod, whatever. So here's another thing. If I have rabbits out in a field, do they just say, oh, we get to multiply once a year? They just keep multiplying, right? That's continuously. So there's things in nature that happen continuously. That's where the number E comes up, and that's why we like it. So let's try some of these problems. Radioactive substance decays in such a way that the amount of mass remaining after T days is given by the function m of T is 23e to the negative 0.0043 T, where m of T is measured in kilograms. Oh boy. You tell me, is this a continuously happening thing or a once a year or twice a year type thing? Continuous because we have E. Okay? A radioactive substance is decaying. And this tells us how much is left. It says find the initial mass. The initial mass will happen at what time? Time 0. So if we were to just figure out m of 0, that would be 23 times e to the negative 0.0043 times 0. That would give us our initial mass. Now, what is negative 0.0043 times 0? Yep. It's 0. And what's anything to the 0 power? 1. So this is 23 times 1, which is? So the mass at time 0, or the initial mass, is equal to 23 kilograms. Okay? That's the initial mass. The second question is, how much of the mass remains after 21 days? How would I calculate after 21 days? I would plug in 21. It tells me at a certain time. So the mass at time 21 is equal to 23 times e to the negative 0.0043 times 21. So I want to calculate that. I plug it in my calculator. E to the negative 0.0043 times 21 is that, times 23 is 21.01. So 21.01 kilograms. That's what's left. And where did I get the E button? I got the E button second ln. Second natural log will give me that. Okay? So far, so good, right? Uh-oh. Levi says no. After how many days does it have half the initial mass? Uh-oh, how do I figure that out? Half of 23 is 11.5. Whoop, hey, don't do that. There we go. Now I'm back. So I got 11.5 is equal to 23e to the negative 0.0043 t. I'm trying to solve for t, right? No, it says after how many days, so we're trying to solve for time, does it have a mass half the initial? The mass is 11.5. The mass is 11.5. How do you solve this equation? This is a logarithmic equation which we've tried to solve before. If I divide by 23, I get 0.5 is equal to e to the negative 0.0043 t. That's a logarithmic equation, which we have been solving. How do you solve for that? How do I access that t up in the exponent? Natural log of both sides. Natural log of both sides. What happens to natural log of e? Goes away, leaves me with the exponent. I end up with the natural log of 0.5, which is negative 0.6931, equals negative 0.0043t. Because when you take a log base e of e, you get, it goes away. Now I divide both sides by negative 0.0043, and I get 161.2. So it's going to take about a half a year for this thing to decay to half its original size. Or half its original mass, I should say. Any questions on problem 1? Yeah. Yep. Okay, let's try number 2. If $1,500 is invested at an interest rate of 8% per year, compounded semi-annually, find the value of the investment after 5, 10, and 15 years. Well, I'm going to use my formula, which says the amount in terms of time is equal to the principal times 1 plus whatever the rate is divided by the number of times per year that it's compounded to the number of times it's compounded times the amount of time that's actually in there. That's my formula. Now I'm going to write an expression for that. I'm not going to plug in the 5, the 10, and the 15 yet. So my amount in terms of time is equal to, what's the principal? What's the initial investment? 1,500 times, parentheses, 1 plus, what is my rate? 0.08 over how many times is it compounded during the year? Twice, semi-annually. Semi-annually means twice a year. To the 2t. Yep. Yep. So t is where we plug in 5, 10, and 15. Now you could do that each time, or we could just plug it into our calculator, into the function spot. And once we do that, we could go to our table and figure out what the values are. So if I go to y equals and I type in 1,500 times parentheses 1 plus what? 0.0, well, 0.08 divided by 2 is 0.04, right? So 0.04 to the parentheses 2x. There we go. So that's my function. Now I can calculate at any specific time. So 5, 10, and 15 years. If I go to my table, there I have it. 5, 10, and 15 would be 2,220, 3,286, and $4,865, respectively, is what I would have after 5, 10, and 15 years. If you didn't put parentheses around the 2 and the x at the end, that could be a problem. You want me to go back to y equals so you can see what you put in? So 1,500 plus 1 plus 0.04 or 1.04 you could just put to the parentheses 2x. If you just do to the second power and then close the parenthesis or something, then it'll just take it to the second and then it'll multiply by x, which is not what we want. Okay, any questions on that? Nope. Wow, you guys are super smart. Okay, let's go to the backside. Which of the given interest rates and compounding periods would provide for the best investment? Let's say you went to the bank and they said, well, you can have 6% and we'll compound it twice a year. Or you can have 5% and we'll compound it 4 times a year. Or you can have 4% and we'll compound it every single day, every single instant. Which would you rather have? I would, yeah, Whitney's right. I would say the 4% continuously. I think that sounds the best. But who knows? We'll have to figure it out. So let's figure out our formula. The amount. Well, these are compounded at certain times. This one's compounded continuously. So we'll use the first formula for the first two and the second formula for the third one. So amount at time t is equal to the principal, which, do we know the principal? Nope, so we'll just write P times 1 plus, what's the rate for the first one? So 0.06 divided by, how many times during the year is 0.6 compounded? Twice. To the 2t. We don't know time either, right? And that would give me an expression. If I work that out, you guys, everybody just kind of pause and take this in real quick. This is 1 plus 0.06 divided by 2 is 1.03, right? Okay, so it's going to be 1.03 to the second power. I could plug in an arbitrary number of years or an arbitrary principal, but we're not going to worry about that. We're just going to write an expression using P and T and see what we get in the middle. Watch. If I just take that portion, 1 plus that, so 1.03, and I square it. That's what this means. 2t. It means squared it and then take it into the t power as well. I would get 1.0609. So really what this comes out to be is the principal times 1.0609 to the t power. Now, I'm going to figure out the others, and whichever number is bigger in the middle here is going to obviously be my best bet. So what we'll do the next one. Amount at a given time would be the principal times 1 plus 0.05 over 4 to the 4t. So now I'll figure that out. 0.05 divided by 4, that's 0.0125 plus 1. And then we'll take that to the 4th power. And we get 1.0509. To the t power. And then for the last one, we have a different formula, don't we? Because it's being compounded continuously. And that formula is going to be the amount at a given time is going to be equal to the principal times e to the rate, right? 0.04 times time. So I guess we need to now figure out what e is to the 0.04 power. Second natural log 0.04. I get 1.0408. So which is the better deal? The first one. It turns out that compounding continuously is probably a really good deal as long as you got the same interest rate. But here we don't have the same interest rate. It drops down to 4. It looks like the interest rate really makes a pretty big difference. So it does. So right now, interest rates for home mortgages are about an all-time low. I mean, when my parents bought their first home, interest rates were like 12, 13%. And now they're like 4. I mean, they're dirt cheap. That's because we're trying to get our economy back on track. Any questions on number 3? Okay, number 4. A man invests $2 grand in an account that is compounded annually at an interest rate of 5.5%. What is the amount in investment after 4 years, and how long does it take the investment to double? Two different problems here. First one's easy. Second one's a little bit more difficult. So you tell me how to get started with the first one. What do I do? So the amount after 4 years is going to be equal to 2,000 annually is 1. Yep, good. So the first key is, can you plug the numbers in correctly? And that's what I have. The amount at 4 years is 2,000 times 1 plus 0.055 over 1 to the 4th power. So we'll do that. 1.055 to the 4th is that times 2,000. Whoop. $2,477. $0.68, something like that. 65. Okay. Want that? Want to make sure the bank gets back those extra 3 pennies. Okay. The next question is a little bit more difficult though. How long does it take for the investment to double? So if we're trying to decide how long it takes, what are we trying to solve for here? Time. I got to solve for time. And it says, how long does it take for the investment to double? So if the investment's doubling, how much is there? 4,000, right? So my initial investment is 2,000. So that means my new I'm wondering, how long does it take to be 4,000? Well, I'll set my equation equal to 4,000. So I have 2,000, or 4,000 equals 2,000 times 1.055 to the t power. How are you going to solve that? Divide by 2,000, so 2 is equal to 1.055 to the t power. This is where everybody got stuck. Very good, Thamansa Stanley. Log base 1.055 of 2 is equal to log base 1.055 of 1.055 to the t power. So I've showed all my work there. That's what we do to both sides. We take the log base 1.055 of each side. What happens to the right side? Cancels out. It just becomes t. So t is equal to, how do I figure out log base 1.055 of 2? Very good. Schuppa-schmat. What do we get? 12.95. 12.95 years it's going to take for your investment to double. Then you can take it back out. Now, it really hasn't truly doubled because if you account for inflation, $4,000 12 years later is not worth what it was, 12 years ago. But it's come. Well, I'm just saying, it's like some people say, it's like, well, I had $1,000 10 years ago. I got $1,000 now, so I saved that $1,000. No, you've actually lost a bunch of money because you should have invested it because inflation's gone up, 3% a year, and you're in trouble. So anyway, well, that's what you get to be my age. You got to start looking at that because like your guys' next big milestone is what, when you turn 18 and then 21. And then when you get a job, you get married, right? My next big stepping stone is when I retire. I mean, all of a sudden you go from, what I mean? So that's a lot of time. It's 30 years. So what I do with my money in that meantime, it matters a lot, right? Maybe I'll just keep on teaching when I'm 90. Yeah, be a good time. Whitney, I could have your grandkids in class someday. Wouldn't that be nice? You could come to conferences still. We could, hang out. Be a good time. Okay. All right. Little bit more difficult problem. Investment of 800 was compounded quarterly over the course of 6 years. The initial investment resulted in $1,245.83. What was the interest rate of the investment? Oh boy. What am I trying to solve for? Rate. Yeah, I'm trying to solve for this part right here. Okay, I'm trying to solve for that. I don't know that. So that's what I got to solve for. So we'll do it. No problems. We can do this. What's my amount? $1,245.83 equals 800 Very good. 1 plus r over 4. Why 4? Compounded quarterly to the 24, because 4 times a year times 6 years would be 24. Whoa. How do I solve that? Divide by 800. That gives me 1.55728. Why did I write it out to so many decimal places? I'm solving for what? Interest rate. And interest rate really makes a big difference. I mean, that's something we want to kind of get down to the 100th for sure. So I've got 5 decimal places going on here. How do I get rid of this 24th power? your instincts are, because we're working with logarithms, to take a log. But remember, logarithms are to get at an exponent. Do we need to get at this 24? We need to get rid of this 24. Don't write this down, but what if it looked like this? What if it looked like this? 8 equals x plus 3 quantity squared. What would you do to both sides? Square root it. So we should 24th root it. No big deal. We take it to what power? 1 over 24. That'll get rid of that power. So I take it to the 1 over 24. Take this to the 1 over 24. And if I do that, I get 1.018627 equals 1 plus r over 4. Now how do you solve that? Subtract the 1, multiply by the 4, right? And you get 0.0745, or 7.45%. Yeah. Yeah. If you take a chemistry class in college, which many of you will, if you take a physics class in college, which some of you will definitely do this. In fact, Newton's law of cooling is in here. This comes up in a calculus class that you would take in college. Do you use it in real life? I have used this when my mortgage people actually sit there. They try to calculate. I say, well, how much money do I have to put down in order for this to work out to such and such a number? And what they do is they do guess and check on their calculator. Now, they're pretty good at it because they do it a lot, but they don't ever come up with the exact amount. I say, well, here's how you do it. So, so that's it. I tell you what, we're not going to do the last problem. We'll allow you guys to start, but I'm going to show you an example where I used math over breaking. You guys can tell me if you can figure it out. So, somebody want to say goodbye to Morgan Field? Who wants to say goodbay to Morgan? Somebody else wants to give a little note to Morgan here.
Bye, Morgan. Hope you're having fun at YIG.
Have fun. We'll You're on YouTube. All right.